All right, hello everybody and welcome. This is section 6.4. Again, this is the Holt-McDougall curriculum, algebra curriculum. And in this section, we're going to be discussing how to solve a linear system by multiplying first. So here's our common core standard that we're meeting over here. It's solving systems of linear equations exactly and approximately. These are the two things that we will be doing in this video. Specifically, you're going to use multiplication first on one equation in order to solve a system of linear equations, and you're going to use multiplication first on both equations in order to solve a system of linear equations. So let's go ahead and move forward and talk about what exactly is multiplying first, or why do we need to do that? So there are times when you cannot use the addition and subtraction method without first altering the system. This being the method that was taught in the last video, 6.3, where we added the two systems together. Now, if I added these two things together, I would get 8x minus 2y equals 36. Now, remember, the goal of the addition and subtraction method is to eliminate something, right? We wanted to make it 0x. But that doesn't happen. And even if we subtract these two systems, or subtract this system, we still don't end up with something being 0. And we can tell that without actually even doing the subtraction, because none of these numbers are the same, right? 5 minus 3 is going to make 2x. 2 minus negative 4 is going to make 6y, a positive 6y. And then this is going to make a negative 4. Addition and subtraction don't work. Neither of those are very helpful in this case because none of the numbers are the same. What we need to do is use multiplication to make it so that when we add or subtract, one of the numbers will eliminate. So what you want to do is look at your equation and say, is there a number that I can multiply one of these equations by to make these numbers the same, right? So is there a number we can multiply 3 by to get 5? No, there isn't. Is there a whole number that we can multiply 5 by to get 3? There isn't. Again, whole number is what I'm thinking here, integer value. What about the y's? Is there a whole number that we can multiply 2 by to get 4? Yes, there is. In fact, if I were to take this entire equation and multiply it by 2, I would end up with 10x plus 4y equals 32. And then this would be 3x minus 4y equals 20. Notice how as long as I multiply everything in that equation by the same number, it is the same equivalent equation. So it's okay to do that, to take everything and scale it by this number over here. Now when I add these things together, I get 13x equals 52. Now it's just like we had with the elimination method where a variable is by itself. And that's what we need to have happen. So let's do a full example together here. So notice adding these together, 6 plus 2 makes 8, 5 plus 3 makes 8. Nothing gets eliminated. I need to look for something that can be multiplied to make the numbers the same. So let's start with my x's. Is there a whole number that I can multiply 2 by to get 6? Yes, there is. If I take this entire bottom equation and I multiply it by 3, this is going to become 6x. Now, what I'm going to do to make my life a little bit easier is I actually don't like using subtraction that much. I always like to add, which means I'm going to try and make this a negative 6 instead of a positive 6. That way I can add and it'll become 0. So I'm going to rewrite my system. The top equation didn't change. It remains the same. The bottom equation, I'm multiplying everything. And again, everything, even the 5 on the other side gets multiplied by the negative 3. So that becomes negative 6. That becomes negative 9y. And this becomes negative 15. Notice we get this nice situation right here where when I add them together, it becomes 0. So it goes away. 5 plus negative 9 gives me negative 4. And that's negative 4y, excuse me. And 19 plus negative 15 is going to make a positive 4. So I now have an equation that can be solved, and I find the y value. And again, remember, this is only half of my solution. My solution is a point. Remember, it is the intersection point of the two lines that we are looking at here. We have the y value. We need the x value. So then we're going to do the exact same thing we did in the last one, in the last two, in fact, is we're going to then plug it into one of these equations. Doesn't matter which one. I'm going to go ahead and plug it into the bottom one. 2x plus 3 times -1 equals 5. And then I simply solve this equation. No changes from the way that we do this, same way that we've been doing it for months. And get the x by itself, and x is 4. Therefore, my answer, therefore, get it? Therefore, the answer, my solution, my intersection point is 4, -1. The point where these two lines intersect is that bad boy right there. Now, I don't know what those lines look like. I could graph them to find out, but that's where they intersect, that point right there. And that's all we have for this video. We've got a sample problem for you back on your Canvas. Please go back and do that problem, and then start the next video to check your answer.